inspector be more likely to find convincing evidence if he looks at a small sample of potatoes? So this is talking about how you increase your power. So the inspector more likely will find convincing evidence with a larger sample. So this little statement right here, more data gives a better chance of making a correct decision. So bigger sample size, more power. All right, and all of these the B and C basically kind of go over how you increase your power. So if you increase your alpha, you decrease your beta. So power is, if you take 1 and you subtract your beta, you're going to increase your power. Okay, so you increase your alpha. On C, the effect size, so it's easier to see the shipment is bad when the actual proportion of bad potatoes is far from hypothesized. Effect size is the difference between the hypothesized value, P0, and the true p-value. So in this case, controlling for other sources of variability by good use of control or blocking or stratifying. So creating an experiment or creating an environment where you control or you block or experimental design, stratify your results, your SRS, or your random sampling, will also increase your power. And I'll give you a little bit more detailed information later on. And then finally, suppose that the true proportion of blemished potatoes is 0.11, and if alpha is 0.05, the power of the test is 0.76. Given that the true proportion of blemished potatoes is P11, there is a 0.76 probability of finding convincing evidence. So basically what they're doing here is the probability of type 2, so 1 minus the power, so 1 minus 0.76 is 0.24. And the way you interpret that is there is a 24% chance or a 0.24 probability of not finding convincing evidence to support the true proportion, or that the true proportion of blemished potatoes is greater than 0.8. So when in reality the true proportion is greater than 0.8. So kind of work through that statement right there and see if you can understand that. We'll talk about that a little bit more in class as well. And then finally down here, when we talk about Benford's law in the fraud case, law and fraud, when the alpha level is 0.05, the power of the test is 0.58. You need to be able to interpret this value. So interpret the power. Given that the true proportion of expenses that begin with 1 is P equals 0.25, there is a 58 or 0.58 probability that there will be convincing evidence that the true proportion is different than 0.301. All right. So how can you need to focus on these right here? How can you increase the power of your test? You can increase the sample size, but of course this is going to cost more money. And I'm talking about AJ&L and Associates, about the law and fraud. You can increase the significance level, but this makes it more likely to needlessly investigate. Or you can use a reasonable stratified sample, but again, that's going to cost money. For what values of P would the power of the test be greater than 0.58? If you have a larger difference between your null and alternative values, because it is easier to detect. And this kind of shows you almost like a margin of error, 0.301 plus or minus the 0.051. Kind of gives you a range, 0.25 to 0.352. So any value that is less than 0.25 and any value that is 0.352 is further away. So basically what they're doing is, if you have a larger difference, so if you look back up, 0.301 was the p-value that we were testing, the null hypothesis, and the 0.501, I believe, is up a couple pages, and you can go see how we calculated that value. All right, now in 9.3a, we haven't really gone over 9.3a too much. It's basically the same as 9.2, except now we're dealing with a population mean. All right, we talk about the conditions, normal, 10%, normal, large. Now remember, since we're dealing with a mean, we've changed it to n is greater than or equal to 30. All right. Your 10% rule when sampling without replacement, so check this, all right, and then making sure that it comes from a well-designed random sample or randomized experiment. Now, because we're dealing with mean, we're going to calculate our instead of a z-score, we're going to calculate our t-score. And remember, it's just a matter of using the correct symbols and just following through with your calculations. The formula is on the formula sheet in the general form. So use this when testing a population mean, except in the rare case when the population standard deviation is known. So if the population standard deviation is known, you're going to use the z-test. All right. So you only use the t-test whenever you don't know the population standard deviation. And then how can you calculate p-values using the t-distribution? Again, remember you have your degrees of freedom, so whatever the sample size is, you subtract 1. And then once you know the level of the confidence and the degrees of freedom, you can calculate your t-statistic from table B and get an estimate of the p-value. Now we also did that on the calculator. You do inverse t in order to find that value. So the p-value is the probability of getting a result this extreme, or more given, the alternative is true. So the probability value is the probability of getting a result this extreme. So what is the, if we have a probability of 0.24, we have a 0.24 probability of getting something this far out. You should graph the t-distribution and draw a border at the calculated t-statistic, all right, just like you would any other z-score. Now we started this and we talked about the 6-inch subs. And if you notice, here's your ICCI in its full form. So we're going to let u equal the true mean length. So we already copied this down. We did the conditions. And here's the graph. Now, because they didn't give us a population proportion, or sorry, a population standard deviation, we're going to draw pictures. You can either do a box plot, box and whisker plot, or a dot plot. Either way, neither one of them shows any skewness, and it doesn't show any outliers. All right. Well, it could show a little bit of skewness, but we're not talking any extreme skewness. Okay. So then you calculate it. The sample mean is your x bar is 5.68 because we are dealing with a mean with a standard deviation of s sub x is 0.66. So here's your 5.68 right here, and then minus your 6 divided by, now look, remember the standard deviation. It's your 0.66 divided by the square root of your sample size, the 24, and you get a t-value of negative 0.238. That's way over here with this red mark. So draw your graph, mark your t-value, okay? Then calculate your p-value. So when you go in and calculate that p-value, you get a p-value of 0.0123. Now let's interpret that. That's a really small amount. It's less than your alpha level of 0.10, so you're going to reject the null hypothesis. In other words, there is convincing evidence that the true length of a 6-inch sub at this restaurant is less than 6 inches. So, and it's actually really apparent to see. If you look at all these, you can actually see that the mean, I mean, there's a lot of them that are, all of these are less than 6-inch subs. So, and that's what you're fighting for, is to get what you pay for. All right. Here again is the Casio calculations. We'll go over the TI, way to work it in your TI. Now, remember to give your conclusion in part A with which kind of mistake. Is it a type 1 or type 2 could you have made? Explain what this mistake would mean in the context of the problem. So, because we rejected the null hypothesis, it is possible we made a type 1 error. In other words, it's possible we found convincing evidence that the mean length was less than 6 inches, when in fact the mean length is not less than 6 inches. Maybe we just chose times that that just happened to have randomness, or that they just served it at those particular times. Maybe we do 50 more samples and they're all above 6 inches. So maybe it was because of the times that we chose. All right, now for a two-sided, remember two-sided is greater than or less than, and you can use your calculator, but yeah, make sure if you do it, show the work that goes with it. Don't just do the calculator work and present it, because you won't get credit for it. All right. If you opt out for the calculator only method, name the procedure and then report the test statistic, degrees of freedom, and p-value. So again, we're going to go over this, break the ice. So I'm not going to cover it right now in the video. The video is already getting a little too long. But at any rate, that's what I want to cover tomorrow. So take a look at this real quick. And let me plug the battery in here. All right. So now I'm going to move this down. Again, here you're going to interpret the standard deviation in part A. And then in part B, what are the two explanations of the X bar being 29.4943? And we'll talk about these two tomorrow, what two explanations you can give. And then the last part is doing your ICCI. Do these data give convincing evidence that the mean width of cubes produced this hour is not 29.5? So we're looking for that it's different, not greater than, not less than, but both, different. So that's when we want our alternative to be not equal to 29.5. And we're going to use the significance test of 0.05. Okay, alpha level of 0.05. Check your conditions. We'll go over that again. And then, of course, your test statistic, because we are dealing with a mean. All right. And I want you to notice how far out they went with that decimal, 0.4943. They went 4 decimal places out. The more you have, the more accurate you're going to have. Draw your t statistic on your graph here and label where that t-value is. And because the degrees of freedom is 49, we had a sample of 50, so degrees of freedom is 50 minus 1, which is 49. You're going to use the more conservative value of 40, because 49 is not on our list, so you always go the one prior. Use your t-distribution with 40 degrees of freedom. The p-value is greater than 2 times 0.25, and remember we did 2 because it's a two-sided, not one-sided. And this is how you use the technology in order to show the work or to check your work. And of course, let's interpret it. Because the p-value of 0.6479 is not less than 0.05, we fail to reject the null hypothesis. We do not have convincing evidence that the true mean width of cubes is not equal to 29.5. Of course, then here's the calculator portion for the Casio, and we can go over the TI later. One of the things you can do is you can use your calculator to do the inverse t in order to find the area of the area to the left without doing all the calculations. Now you need to show your work still, but this kind of helps you double check. All right, and then of course you double it, and then because the hypothesized mean is 29.5 is in the range. So if you notice, this right here kind of gave you a interval, confidence interval, that you can say, well, 29.5 is within this range. In fact, it's a little bit less than 29.52, so therefore there is no convincing evidence, and that confidence interval even further proves that point. All right? And then, of course, paired data and using test wisely. We're going to talk about pairing two items together. So I'm going to talk about this tomorrow, but I'm going to just let you have the notes. Look at the graph. I'm going to go down a little bit. Here's your normal probability plot. We'll talk about that as well. Normal large sample. All right, so the graphs don't show much skewness. There's no outliers, so it is reasonable to use a t procedure for these data. Calculate. Here's your x bar for d and your standard deviation of x, so 84. All right, here's your test statistic, your t-value, and then of course here's all the information you need to be able to list. And of course, to compute the paired difference, navigate to the head of listening. So this is kind of putting data in your stat mode. Okay? And then finally, here's the last bit of it. What is the difference between statistical and practical significance? We'll talk about this tomorrow. Make sure you've read up on it. And then here's some exam tips to get ready for your test. When writing your hypothesis statement, define the parameter. Writing your conclusion, do not refer to the sample statistic, the sample, or the data. And of course, you can read the rest of this on your own. And that is it. Thank you for listening, and look forward to seeing you in class tomorrow.